Hello my dear students, welcome back to chemistry online class. So in the previous class already we solved the number of numerical problems based on the stoichiometry and the stoichiometric calculation part. And under this stoichiometry and stoichiometric calculation already we covered the problems under mass to mass relationship, second one is mass to volume relationship, third one is mass to mole relationship, and the fourth important relation is mole to mole relationship, students. And now the next important concept under this some basic concept of chemistry related to the stoichiometry and stoichiometric calculation. The next important concept is the limiting reagent concept. See here, limiting reagent and one more terminology called as excess reagent. And you please recall the stoichiometry and the stoichiometric calculation, and this concept it is completely based on the stoichiometric calculations only. And here limiting reagent. The limiting reagent means the reagent which is completely consumed during the chemical reaction is called as limiting reagent. Listen the definition of limiting reagent, students. What is limiting reagent here? In an chemical reaction, the substance one which is completely consumed during the chemical reaction is called as limiting reagent. Whereas on the other hand, the substance one which is not completely consumed, in such cases we call it as an excess reagent, students. One is excess reagent and the second one is called as the limiting reagent. I repeat the definition of excess reagent. The substance one which is not completely consumed during the chemical reaction is called as excess reagent, students. And here in case of limiting reagent, all quantitative calculations are carried out with the help of this limiting reagent. Please listen this sentence carefully. Almost all the quantitative calculations are carried out with the help of this limiting reagent. And in case of limiting reagent, the amount of product formed depends on the quantity of limiting reagent in the given chemical reaction or in the given chemical equation. Students, you please listen these two sentences in the limiting reagent carefully. So always in case of limiting reagent concept, almost all the quantitative calculations are carried out with the help of this limiting reagent. And in the chemical reactions or in the chemical equations, the amount of product formed or the quantity of product formed always depends on the quantity of limiting reagent. You please remember the last sentence about limiting reagent. It is very helpful while calculating the amount of product formed. That amount of product formed or the quantity of product formed always it depends on the limiting reagent only, students. And here limiting reagent. So let us take an example. Of A plus of B, it forms product. So this is the chemical equation. A plus B combine to form product P, and in this chemical equation two reactants are present, one is A and one is B, and out of these two chemical substances one of the substance is completely consumed during the chemical reaction, whereas on the other hand the second substance is not completely consumed. Please listen the example carefully. ನೋಡ್ರಿ ಇಲ್ಲಿ ಏನು ಬರ್ತದಲ್ಲ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್, ಈ ರಿಯಾಕ್ಷನ್ ಒಳಗ A ಮತ್ತು B ಏನಿದಾವಲ್ಲ, these two are reactants and P means it is nothing but a product, and out of these two reactant one of the reactant is completely consumed. ಅಂದ್ರೆ ಎರಡು ರಿಯಾಕ್ಟೆಂಟ್ ಒಳಗ ಒಂದು ರಿಯಾಕ್ಟೆಂಟ್ ಕಂಪ್ಲೀಟ್ ಆಗಿ ರಿಯಾಕ್ಷನ್ ಒಳಗ ಯೂಸ್ ಆಗುತ್ತೆ and one more reactant remains unreacted. Let us take an example. So 2 moles of reactant A combines with 3 moles of reactant B to form say 1 mole of product P. ಹೌದಾ? ಸೊ ಇಕ್ವೇಶನ್ ಪ್ರಕಾರ 2 moles of reactant A 3 moles of reactant B ಜೋಡಿ ರಿಯಾಕ್ಟ್ ಆಗಿ ನಮಗೆ 1 mole of product ಅನ್ನ ಕೊಡುತ್ತೆ. ಹೌದಾ? ಸೊ ಎಷ್ಟಿದಾವ್ರಿ ಇಲ್ಲಿ ಕ್ವಾಂಟಿಟಿ ನಮಗೆ 2 moles and here how many moles of B students? 3 moles of B. The available number of moles are 2 and available number of moles are 3 here. And out of these two chemical substances, in some of the problems, only 1 mole of reactant A is used and all the 3 moles of reactant B is used. Listen the explanation carefully. ಅಂದ್ರೆ ಕೆಲವೊಂದು ಪ್ರಾಬ್ಲಮ್ ಒಳಗ ಈಗ ನಮ್ಗೆ ಅವೈಲೇಬಲ್ ಎಷ್ಟಿದಾವೆ 2 moles ಇದಾವ. ಈ 2 moles ಒಳಗ 1 mole of reactant ಅಷ್ಟೇ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ 3 moles ಅಲ್ಲಿ all the 3 moles of reactant reacted in the chemical reaction. ಅಂದ್ರೆ 3 moles ಇತ್ತು, all the 3 moles ಯೂಸ್ ಆಗು. ಈ 2 moles ಒಳಗ 1 mole ಅಷ್ಟೇ ಯೂಸ್ ಆಯ್ತು. ಹೌದಾ? ಇಲ್ಲಿ 3 moles ಇತ್ತು, all the 3 moles ಯೂಸ್ ಆಯ್ತು. That means the B is completely consumed during the reaction. So therefore it is called as a limiting reagent. Whereas on the other hand, reactant A out of 2 moles, say in some example only 1 mole of reactant A is used. ನೋಡಿ ಬರೀ ಒಂದೇ 1 mole ಯೂಸ್ ಆಯ್ತು. 1 mole ಯೂಸ್ ಆಗಿ ಇನ್ನೂ 1 mole ನಮಗೆ ಉಳಿಯಿತು ಅಂತಂದ್ರೆ ಅದನ್ನ ನಾವು ಎಕ್ಸೆಸ್ ಅಂತ ಕರಿತೀವಿ, which is not completely consumed during the chemical reaction. And you please recall the definition of a limiting reagent. The limiting reagent, it is defined as the reagent or the chemical substance which is completely consumed during the chemical reaction is called as a limiting reagent. And always in the calculation related to this limiting reagent concept, the amount of a product formed or the quantity of a product formed depends on the quantity of a limiting reagent, students. So this is about the limiting reagent concept, and here you please remember the definition of a limiting reagent and this third sentence related to limiting reagent, students. Okay, any doubt in this concept? Definition clear aita nimge? So now we'll solve the problems based on this limiting reagent by using the stoichiometric calculation part. Okay, once we start solving the numerical problem, then you come to know how to identify the limiting reagent and how to identify the excess reagent in a chemical reaction, students. Is there any doubt in this explanation? And one more thing you keep it in mind, always this limiting reagent concept is applicable for the chemical reaction or it is applicable for the chemical equation which contains only 2 reactants. ಅಂದ್ರೆ ಎರಡು ರಿಯಾಕ್ಟೆಂಟ್ ಇದ್ದರೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಜನರಲಿ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಅಪ್ಲಿಕೇಬಲ್ ಮಾಡ್ಕೊತಾ ಹೋಗ್ತೀವಿ. ಓಕೆ, ಸೊ ನಾವು ಬೇಸ್ಡ್ ಆನ್ ದಿಸ್ ಲಿಮಿಟಿಂಗ್ reagent, let us start the first problem. Listen this first problem carefully. Identify the limiting reagent if any in the following reaction mixture. Listen the question. Identify the limiting reagent if any in the following reaction mixture. And already the reaction mixture is given. A plus B2, it gives AB2. This is the equation. A plus B2, it gives AB2. So in this reaction mixture, the first question is 300 atoms of A plus 200 molecules of B2. Second question, 100 atoms of A plus 100 molecules of B2. Then third question, 5 moles of reactant A and 2.5 moles of reactant B2. Then fourth question, 2.5 moles of A plus 5 moles of B2. And the fifth question is 2 moles of A plus 3 moles of B2. This is the question, students. Please listen the solution carefully. So here the reaction. Let us start the solution for this first problem. So what is the reaction mixture, students? So the reactant A, when it combines with B2, it forms AB2. So this is our reaction mixture. And according to this balanced chemical equation, let us explain or let us express the reactants and products in this reaction mixture in terms of number of moles. You please recall this stoichiometric calculation. See, according to this balanced chemical equation, yes, tell me students, what is the stoichiometric coefficient here? What is stoichiometric coefficient? Yes, 1 is the stoichiometric coefficient. That means 1 mole of reactant A, 1 mole of reactant A combines with 1 mole of reactant B2. It forms 1 mole of product AB2. This is according to the balanced chemical equation. Students, you please try to understand this concept carefully. 1 mole of reactant A combines with 1 mole of reactant B2. It forms 1 mole of product AB2. And in this reaction mixture, reactant A, it is in the form of atom. So 1 mole of reactant A, 1 mole of reactant A means it is nothing but 1 atom of A. So it is nothing but 1 atom of A. 1 mole of reactant B2. B2 means it is in the form of molecule. B2 means it is made up of 2 identical B. That means it is a molecule. 1 mole of B2 is nothing but 1 molecule of B2. 1 mole of B2 andru ande, 1 molecule of B2 anta kadru ande. Now on the right hand side, 1 mole of AB2, or you can write it as 1 molecule of AB2. Students, please try to understand this explanation carefully. ನೋಡಿ, ರಿಯಾಕ್ಷನ್ ಮಿಕ್ಸರ್ ಒಳಗ A ಅನ್ನೋ ರಿಯಾಕ್ಟೆಂಟ್ ಅಟೋಮಿಕ್ ಫಾರ್ಮ್ ಒಳಗಿದೆ, B2 ಅನ್ನೋ ರಿಯಾಕ್ಟೆಂಟ್ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮ್ ಒಳಗಿದೆ, AB2 ಅನ್ನೋ ಪ್ರಾಡಕ್ಟ್ ನಮಗೆ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮ್ ಒಳಗಿದೆ. ಸೊ ಅದಕ್ಕೆ ನಾನು ಏನ್ ಮಾಡಿದೆ ಇಲ್ಲಿ, ಫಸ್ಟ್ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಮತ್ತೆ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅನ್ನ ಮೋಲ್ ಒಳಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಿದ್ದೀನಿ. ಸೆಕೆಂಡ್ ಕೇಸ್ ಒಳಗೆ ಸೇಮ್ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಅಂಡ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಆರ್ ಎಕ್ಸ್ಪ್ರೆಸ್ಡ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ನಂಬರ್ ಆಫ್ ಆಟಮ್ಸ್ ಅಂಡ್ ನಂಬರ್ ಆಫ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್. ಸ್ಟೂಡೆಂಟ್ಸ್, is there any doubt in this first explanation? This point is clear for you. 1 mole of reactant A, it is nothing but 1 atom of A. 1 mole of reactant B2, it is nothing but 1 molecule of reactant B2. Similarly, 1 mole of product AB2, it is nothing but 1 molecule of product AB2. Students, is any doubt in this general explanation? This point is clear. Now, with the help of this general explanation, so let us start first problem. Now in this first problem, 300 atoms of A plus 200 molecules of B2. So 2 reactants are present in the reaction mixture. Yes, tell me students, what are those 2 reactants? Yes, tell me what are those 2 reactants in the reaction mixture? Yes, very good. One is reactant A and the second one is reactant B2. So 2 reactants are present. Now we have to identify out of these 2 reactants which one is act as an excess and which one is act as a limiting reagent. So the first problem, so 300 atoms of A plus 200 molecules of B2. So let us write the reaction mixture here. Reactant A combines with the reactant B2, it forms product AB2. This is the reaction mixture. And according to this reaction mixture, according to this balanced chemical equation, 1 atom of A react with 1 molecule of B2. ನೋಡಿ, balanced equation ಪ್ರಕಾರ 1 atom of A, it combines with 1 molecule of B2. But in the problem, 300 atoms of A combines with 200 molecules of B2 are given. Let us calculate how many atoms of A required to react with 200 molecules of B2. Please listen this explanation. ನಮಗೆ ಇಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಒಳಗೆ ಎರಡನ್ನೂ ಕೊಟ್ಟಿದ್ದಾರೆ. 300 atoms of A ನು given, 200 molecules of B2 is also given. ಅದರೊಳಗೆ ಯಾವುದಾದ್ರೂ ಒಂದು ಕ್ವಾಂಟಿಟಿನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. ಐದರ್ ಯು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಹೌ ಮಚ್ ಅಟಮ್ಸ್ ಆಫ್ A required or you calculate how much molecules of B2 are required. ನೋಡಿ, ಇಲ್ಲಿ ನಾನು ಫಸ್ಟ್ ಏನ್ ಮಾಡ್ತಿದ್ದೀನಿ, A ಅಟಮ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಿದ್ದೀನಿ. ಅಂದ್ರೆ ಬ್ಯಾಲೆನ್ಸ್ಡ್ equation ಪ್ರಕಾರ one atom of A combines with one molecule of B2, so therefore X atoms of A combines with 200 molecules of B2. Now you cross multiply these two. X equal to 200 into 1 divided by 1. What is the answer, students? 200 atoms. Listen this point carefully. How many atoms are required to react with the 200 molecules of B2 here? 200 atoms are required. These many number of atoms A are required, students. ಅಂದ್ರೆ ನಮಗೆ ಎಷ್ಟು ಬೇಕು ಇಲ್ಲಿ 200 atoms ಬೇಕು. ಬಟ್ ನಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಒಳಗೆ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 300 atoms are given. ನೋಡಿ ರಿಕ್ವೈರ್ಡ್ ಇರೋದು ಜಸ್ಟ್ 200 ಬಟ್ ಗಿವನ್ ಇರೋದು ಎಷ್ಟು 300. ಅಂದ್ರೆ ಆ 200 ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಇನ್ನೂ ನಮಗೆ 100 ಅಟಮ್ಸ್ ಏನಾಗ್ತಾವ ಉಳಿತಾವ. ಅಂದ್ರೆ ನಾವು ಏನಂತೀವಿ, ದಿಸ್ A is called as a excess reagent. If you find excess means the other one is nothing but limiting reagent only. ಅಂದ್ರೆ 300 ಅಟಮ್ಸ್ ಇದಾವು, ಅವೈಲೇಬಲ್ 300, ರಿಕ್ವೈರ್ಡ್ ಎಷ್ಟು ಜಸ್ಟ್ 200. ಓಕೆ, ಸೊ ಈ 200 ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಮಗೆ ಇನ್ನೂ 100 ಅಟಮ್ಸ್ ಉಳಿತವೆ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಏನಂತ ಕರೀತೀವಿ, ಎಕ್ಸೆಸ್ ರಿಯೇಜೆಂಟ್ ಅಂತ ಕರೀತೀವಿ. ಇಫ್ A is act as a excess reagent means which one is called as a limiting reagent, students? B2 is act as a limiting reagent. So this is the first problem. ಹೌದಾ, ನಾನು ಇಲ್ಲಿ A ತಗೊಂಡು ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಮಾಡಿದ್ದೇನೆ. ಹೌದಾ, or according to the equation, one atom of A combines with one molecule of B2. This is according to the balanced equation. One atom of A combines with one molecule of B2. So therefore X molecules of B2 required to react with 300 atoms of A. ನೋಡಿ ಪ್ರೀವಿಯಸ್ ಕೇಸ್ ಒಳಗೆ ನಾನು ಏನ್ ಮಾಡಿದ್ದೆ, ನಂಬರ್ ಆಫ್ ಅಟಮ್ಸ್ ಆಫ್ A ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ ಬೈ ಯೂಸಿಂಗ್ ನಂಬರ್ ಆಫ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ B. ಹೌದಾ, ಸೊ ಈಗ ನಾನು ಸೆಕೆಂಡ್ ಏನ್ ಮಾಡ್ತಿದ್ದೀನಿ, ಸೊ ಯೂಸ್ ನಂಬರ್ ಆಫ್ ನಂಬರ್ ಆಫ್ ಅಟಮ್ಸ್ ಆಫ್ A ಅಂಡ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ನಂಬರ್ ಆಫ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ B. ಓಕೆ, ಸೊ ಒನ್ಸ್ ಅಗೇನ್ ಯು ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ದೀಸ್ ಟು. X equal to 300 into 1 denominator 1. So tell me students, what is the answer here? 300 molecules. So 300 molecules of B2 are required to react with 300 atoms of A. Listen, this is second explanation carefully. Balanced equation ಪ್ರಕಾರ one atom of A, one molecule of B2 ಜೋಡಿ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಹೌದಾ, ಹಾಗಾದ್ರೆ 300 atoms of A ಎಷ್ಟು ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ B ಜೋಡಿ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಸೊ B molecules ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ, ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ, ಎಷ್ಟು ರಿಕ್ವೈರ್ಡ್ ಇದೆ? 300 molecules of B2 are required. ಅಂದ್ರೆ ಬೇಕಾಗಿರೋದು ಎಷ್ಟಪ್ಪ ನಮಗೆ? 300. ಬಟ್ ಅವೈಲೇಬಲ್ ಎಷ್ಟು ಪ್ರಾಬ್ಲಮ್ ಒಳಗೆ? ಓನ್ಲಿ 200 molecules are available. Therefore all these 200 molecules are completely consumed in the chemical reaction. So therefore it is called as a limiting reagent. So either you can solve first one or you can solve this second one. ನೀವು ಇದನ್ನ ಏನಾದ್ರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಲಿಮಿಟಿಂಗ್ ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಿ, ಅಥವಾ ಬಿ ನಾದ್ರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಲಿಮಿಟಿಂಗ್ ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಿ. ಚಾಯ್ಸ್ ಇಸ್ ಯುವರ್ಸ್. ಯಾವ್ದಾದ್ರು ಒಂದು ತಗೊಳ್ರಿ, ಎರಡನ್ನೂ ಮಾಡೋದು ನೆಸೆಸರಿ ಇಲ್ಲ. ಈಗ ನೀವು ಫಸ್ಟ್ ಮೆಥಡ್ ಫಸ್ಟ್ ತಗೊಂಡು ಮಾಡಿದ್ರೆ ಏನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ಎ ನಮಗೆ ಏನಾಯ್ತು, ಇಲ್ಲಿ ಎಕ್ಸಸ್ ರಿಯೇಜೆಂಟ್ ಆಯ್ತು. ಹೌದಾ, ಎ ಅನ್ನೋದು ಏನಾಯ್ತ್ರಿ? ಎಕ್ಸಸ್ ರಿಯೇಜೆಂಟ್ ಆಯ್ತು. ಬಟ್ ಸೆಕೆಂಡ್ ತಗೊಂಡಾಗ ಡೈರೆಕ್ಟ್ಲಿ ವಿಲ್ ಗೆಟ್ ದಿ ಲಿಮಿಟಿಂಗ್ ರಿಯೇಜೆಂಟ್. B2 ನ ನಮಗೆ ಲಿಮಿಟಿಂಗ್ ರಿಯೇಜೆಂಟ್ ಆಯ್ತು. Clear ಆಯ್ತಾ? If A is act as excess reagent means the other substance is called as a limiting reagent. No need to calculate the second one. Okay, excess ಬಂತು ಅಂತಂದ್ರೆ ಇನ್ನೊಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಲಿಮಿಟಿಂಗ್ ರಿಯೇಜೆಂಟ್ ಇದ್ದಾಗ. ಕ್ಲಿಯರ್ ಆಯ್ತಾ ಕಾನ್ಸೆಪ್ಟ್ ಇದು? So this is the first question. Okay, so tell me which one is a limiting reagent here. So reactant B2 is called as a limiting reagent in this first problem, students. Is it clear? Any doubt in this problem? ಎಷ್ಟು ನಿಮಿಷ ಇದ್ದೀನಿ ನೋಡಿ? 7 minutes. Now the second explanation, listen, the second problem in the reaction mixture. The second problem, 100 atoms of A plus 100 molecules of B2. Listen this second problem. So once again write the balanced chemical equation. So A plus of B2, A plus of B2, it gives AB2. This is our balanced chemical equation. According to this balanced chemical equation, one atom of A combines with one molecule of B2. You please recall this general explanation part, students. ಹೌದಾ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಈಕ್ವೇಶನ್ ಪ್ರಕಾರ one atom of A ಏನಾಗುತ್ತೆ one molecule of B2 ಜೋಡಿ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. Then what is the second question here? 100 atoms of A and 100 molecules of B2 are given. So use any one of these two data and calculate other one. So let us use 100 atoms of A. According to the equation, one atom of A react with one molecule of B2. So therefore, 100 atoms of A react with X molecules of B2. Now cross multiply these two. X equal to 100 into 1 divided by 1. What is the answer, students? 100 molecules. Listen this point carefully. ಅಂದ್ರೆ one atom of A one molecule of B2 ಜೋಡಿ ರಿಯಾಕ್ಟ್ ಆಯಿತು ಅಂತಂದ್ರೆ 100 atoms of A required to react with 100 atoms of A are required to react with 100 molecules of B2. ಅಂದ್ರೆ one atom of A one molecule of B2 ಜೋಡಿ ರಿಯಾಕ್ಟ್ ಆಗ್ತಂದ್ರೆ 100 atoms of A ರಿಯಾಕ್ಟ್ ಆಗಬೇಕು ಅಂದ್ರೆ 100 molecules of B2 are required. How many molecules of B2 are given in the problem? 100 molecules only. ಹೌದಾ ಎಕ್ಸಾಕ್ಟ್ 100 ಇದೆ ನಮ್ಮ ಕಡೆ. So required 100, available 100. ಹೌದಾ so now similarly so let us take one more. Or one atom of A combines with one molecule of B2, therefore X atoms of A combines with 100 molecules of B2. Cross multiply. Once again X equal to 100 into 1 divided by 1. What is the answer? 100 atoms of A are required. So in this second problem, neither A is act as a limiting reagent nor B2 is act as a limiting reagent, students. ನೋಡ್ರಿ ಏನು ನಮಗೆ ಲಿಮಿಟಿಂಗ್ ರಿಯೇಜೆಂಟ್ ಅಲ್ಲ, B2 ನಮಗೆ ಲಿಮಿಟಿಂಗ್ ರಿಯೇಜೆಂಟ್ ಅಲ್ಲ. ಕ್ಲಿಯರ್ ಆಗ್ತದೆ ನಿಮಗೆ ಕಾನ್ಸೆಪ್ಟ್ ಇದು? ಯಾಕಂದ್ರೆ ಎರಡೂ ಸೇಮ್ ಇದಾವೆ. ರಿಕ್ವೈರ್ಡ್ ಎಷ್ಟು ಇದಾವಲ್ಲ, ಸೇಮ್ ನಂಬರ್ ಆಫ್ ಅಟಮ್ಸ್ ಅಂಡ್ ಸೇಮ್ ನಂಬರ್ ಆಫ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆರ್ ಅವೈಲೇಬಲ್ ಇನ್ ದಿ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, therefore in this second problem neither reactant A is act as a limiting reagent nor reactant B2 is act as a limiting reagent, students. Is there any doubt in this problem? ನೋಡಿ ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೋಬೇಡ್ರಿ. ಆಲ್ರೆಡಿ ಕ್ವಾಂಟಿಟೀಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ. ಹೌದಾ 100 atoms of A 100 molecules of B2, 300 atoms of A 200 molecules of B2 given quantity ಅದು. ಬಟ್ ಅದರೊಳಗೆ ಯಾವ್ದಾದ್ರು ಒಂದನ್ನು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಇನ್ನೊಂದನ್ನು ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಅಂದ್ರಷ್ಟೇ ನಾವು ಲಿಮಿಟಿಂಗ್ ಅನ್ನ ಮತ್ತೆ ಎಕ್ಸಸ್ ಅನ್ನ ಐಡೆಂಟಿಫೈ ಮಾಡ್ಬೋದು. ಹೌದಾ ನಿಮಗೆ ಕನ್ಫ್ಯೂಷನ್ ಏನಂದ್ರೆ ಎರಡೂ ಗಿವನ್ ಡಾಟಾ ಕೊಟ್ಟಿದ್ದಾರೆ ನಮಗೆ, ಮತ್ತೆ ನೀವು B2 ನ ಅಥವಾ A ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಾ ಅಂತ ಹೇಳಿ. ಲಿಮಿಟಿಂಗ್ ರಿಯೇಜೆಂಟ್ ನ ನಾವು ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಅನ್ನ ತಗೊಂಡು ಇನ್ನೊಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. Either you take number of atoms and calculate number of molecules, or use number of molecules and calculate number of atoms. So students, is there any doubt in this second problem? Second problem is clear for you. Second solution clear ಆಯ್ತಾ? First problem ಒಳಗೆ reactant A is a excess and reactant B2 is called as limiting reagent, and in the second problem neither A is act as a limiting nor B2 is act as a limiting reagent, students. Is there any doubt in this second problem? Is it clear? Okay. Now the third problem is 5 moles of reactant A plus 2.5 moles of reactant B2. Now the third one is 5 moles of A plus 2.5 moles of B. Listen the third problem, students. The given reaction mixture is A plus B2 AB2. This is the balanced chemical equation. And you please recall the general explanation. According to the balanced chemical equation, 1 mole of reactant A combines with 1 mole of reactant B2. 1 mole of reactant A combines with 1 mole of reactant B2. And the third problem is 5 moles of A combines with 2.5 moles of B2. So according to the equation, 1 mole of reactant A combines with 1 mole of reactant B. Therefore, 5 moles of reactant A combines with X moles of reactant B. Let us use number of moles of A and calculate number of moles of B2 here. Now to cross multiply these two, X equal to 5 into 1 divided by 1. What is the answer, students? 5 moles. 5 moles of B2 are required. Listen this point carefully. The balanced equation ಪ್ರಕಾರ 1 mole of A 1 mole of B2 ಜೋಡಿ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ 5 moles of reactant A X moles of reactant ಜೋಡಿ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ X ಅಂದ್ರೆ ಎಷ್ಟು ಇಲ್ಲಿ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ರಿ 5 into 1 divided by 1. So how many moles of B2 are required? 5 moles are required. But in the problem, how many moles are available? 2.5. So 2.5 moles of B2 are available. But required is how much? 5 moles, students. So therefore, these 2.5 moles of B2 are completely consumed during the chemical reaction. So that's why the reactant B2 in this problem is act as a limiting reagent. Is there any doubt? Is it clear? ನೋಡ್ರಿ ರಿಯಾಕ್ಟೆಂಟ್ ನಮಗೆ B2 ರಿಕ್ವೈರ್ಡ್ ಎಷ್ಟು 5 moles ಬೇಕು. ಬಟ್ ನಮಗೆ ಅವೈಲೇಬಲ್ ಎಷ್ಟಿದಪ್ಪ? ಜಸ್ಟ್ 2.5 moles ಇದೆ. 2.5 moles ಇದೆ ಅಂತಂದ್ರೆ all these 2.5 moles are completely consumed in the reaction. Still we require 2.5 moles. So therefore it is called as a limiting reagent, students. Is it clear? Any doubt in this? Otherwise, you can take number of moles of A and calculate number of B, or number of moles of B and calculate number of moles of A. Is it clear? Now the fourth problem. The fourth problem in this question is 2.5 moles of A plus 5 moles of B2. ನೋಡಿ ಪ್ರೀವಿಯಸ್ ಕೇಸ್ ಒಳಗ 5 moles of A ಮತ್ತು 2.5 moles of B2 ಕೊಟ್ಟಿದ್ರು. ಬಟ್ ಈ ಫೋರ್ತ್ ಪ್ರಾಬ್ಲಮ್ ಒಳಗ 2.5 moles of A plus 5 moles of B2 ಕೊಟ್ಟಿದ್ದಾರೆ. And already you know which one is act as a limiting reagent in the previous problem. Yes, tell me students, out of A and B2, which one is act as a limiting reagent in the third problem? B2 is called as a limiting reagent in the third problem. Then which one is excess reagent here? Reactant A is called as an excess reagent here. And now the fourth one. And before solving this fourth problem, once again you write the reaction mixture A plus B2. The product is AB2. And you write the general explanation according to the balanced chemical equation. 1 mole of atom A combines with 1 mole of molecule B2. So now, according to the balanced chemical equation, 1 mole of reactant A combines with 1 mole of reactant B2. So therefore 2.5 moles of reactant A react with X moles of reactant B. ನೋಡಿ ನಾನು A ತಗೊಂಡು B ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಿದ್ದೀನಿ, ಇಲ್ಲ ನೀವು B ತಗೊಂಡು A ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. ಚಾಯ್ಸ್ ಇಸ್ ಯುವರ್ಸ್. ಹೌದಾ? A ತಗೊಂಡು B ನಾದ್ರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು ಅಥವಾ B ತಗೊಂಡು ನಾವು A ನಾದ್ರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಸೊ ನಾವು 2.5 moles of reactant A combines with X moles of reactant B. Now we cross multiply these two. X equal to 2.5 into 1 divided by 1. What is the answer, students? So 2.5 moles. So these many moles of reactant B2 are required. Listen this point carefully. ಎಷ್ಟು ಬೇಕ್ರಿ ನಮಗೆ? 2.5 moles ಬೇಕು. ಅದರ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಈಕ್ವೇಶನ್ ಪ್ರಕಾರ 1 mole of reactant A ರಿಯಾಕ್ಟ್ ಆಗಬೇಕು ಅಂತಂದ್ರೆ 1 mole of reactant B2 ಬೇಕು. ಅಂದ್ರೆ ಈಕ್ವೇಶನ್ ಪ್ರಕಾರ 1 mole react with 1 mole of B2. So therefore 2.5 moles of reactant A combines with 2.5 moles of reactant B2. ಅಂದ್ರೆ ಎಷ್ಟು ಬೇಕು ನಮಗೆ? B2 2.5 ಬೇಕು. Required are 2.5 moles, but available number of moles of B2 are 5. ನೋಡಿ ನಮಗೆ required just 2.5, available ಇರೋದು ಎಷ್ಟಪ್ಪ ನಮಗೆ? 5 moles of B2 are available. That means the available number of moles are more than that of required B2, it is called as an excess reagent. ನೋಡಿ ಯಾಕೆ ನಾವು ಎಕ್ಸಸ್ ಅಂದ್ರೆ ಅವೈಲೇಬಲ್ ನಮಗೆ ಇರೋದು 5 ಮೋಲ್ಸ್ ಇದಾವು, ಬಟ್ ನಮ್ಗೆ ಬೇಕಾಗಿರೋದು ಜಸ್ಟ್ 2.5 ಮೋಲ್ಸ್. ಹೌದಾ? ಅವೈಲೇಬಲ್ ಇರೋದು 5 ಮೋಲ್ಸ್, ಸೊ ರಿಕ್ವೈರ್ಡ್ 2.5 ಮೋಲ್ಸ್. ಅಂದ್ರೆ 2.5 ಮೋಲ್ಸ್ ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡ್ರು ನಮ್ಗೆ ಇನ್ನೂ 2.5 ಮೋಲ್ಸ್ ಎಕ್ಸಸ್ ಉಳಿತಾವೆ. ಅದಕ್ಕೆ ನಾವು ಎಕ್ಸಸ್ ರಿಯೇಜೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಅಂದ್ರೆ if B2 is act as an excess reagent means can you tell me which one is called as a limiting? A is called as a limiting reagent students. ಹೌದಾ? ನೋಡಿ ಇಲ್ಲಿ ನಾನು A ತಗೊಂಡು B ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದೀನಿ. ಇಲ್ಲಪ್ಪ ನಾನು B ತಗೊಂಡು A ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ 1 mole of reactant A combines with 1 mole of reactant B, so therefore x moles of reactant A combines with 5 moles of reactant B. Cross multiply ಮಾಡ್ರಿ. X equal to 5 into 1 divided by 1. How many moles of reactant A are required? 5 moles are required. ಎಷ್ಟು ಬೇಕ್ರಿ? A ಐಟಮ್ 5 moles ಬೇಕು, ಬಟ್ ಅವೈಲೇಬಲ್ ಎಷ್ಟಿದೆ ಇಲ್ಲಿ? just 2.5. required quantity is more than that of available quantity, hence this one is called as a limiting reagent. So in this fourth problem, A is called as a limiting and B is called as a excess reagent. Is there any doubt in this fourth problem, students? Is it clear? Okay, then the last one. 2 moles of reactant A plus 3 moles of reactant B2. Now we have 2 moles ಒಳಗೆ ಇದಾವು. So once again we go for general explanation. Write the balanced equation. A plus of B2, then product is AB2. Express reactants and products in terms of mole. 1 mole of reactant A combines with 1 mole of reactant B, it produces 1 mole of product AB2. And according to the balanced equation, 1 mole of reactant A combines with 1 mole of reactant B. So therefore, x moles of reactant A combines with 3 moles of reactant B. ನೋಡ್ರಿ ನಾನು A ನ x ಅಂತ ತಗೊಂಡು B ನ 3 moles ಅಂತ ಯೂಸ್ ಮಾಡಿದ್ದೀನಿ. ಅಂದ್ರೆ B ನ ತಗೊಂಡು A ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀನಿ. ಹೌದಾ? So 1 mole of A combines with 1 mole of B2, therefore x moles of A combines with 3 moles of B2. So x equal to 3 into 1 divided by 1. What is the answer, students? 3 moles. So 3 moles of A are required. ಅಂದ್ರೆ ಎಷ್ಟು ಮೋಲ್ ಆಫ್ A ಬೇಕು ನಮಗೆ? 3 moles of A ಬೇಕು. But problem ಒಳಗೆ ನಮಗೆ ಎಷ್ಟು ಮೋಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ? just 2 moles are given. That means required quantity is more than that of available quantity. So that's why reactant A is called as a limiting reagent. ನೋಡ್ರಿ, available is 2 but required is 3. Therefore all these 2 moles of reactant A are completely consumed in the reaction, hence it is called as a limiting reagent, students. If A is called as a limiting reagent means which one is excess here? B2 is called as excess reagent. Any doubt in this problem? Or you can take A and calculate B also. 1 mole of A combines with 1 mole, therefore 2 moles of A combines with x moles of B2. So cross multiply. X equal to 2 into 1 divided by 1. How many moles of B2 are required? 2 moles of B2 are required. Then what about available number of moles of B2, students? 3 moles are available. Required quantity is less than that of available quantity, hence B2 is called as excess reagent here. So A is called as a limiting and B2 is called as the excess reagent. Is there any doubt in this problem, students? All these 5 problems are clear? Concept clear ಆಗ್ತದೆ ನಿಮಗೆ? Yes. The second problem is in the reaction 2A plus 4B, it gives 3C plus 4D. See, the balanced equation is given in the problem. Let us write the balanced equation first. So what is the balanced equation here? 2A plus 4B, right hand side 3C plus 4D. This is our balanced chemical equation. In this balanced chemical equation, 5 moles of A are react with 6 moles of B. 5 moles of reactant A are react with 6 moles of B, then identify the limiting reagent and calculate the amount of C formed. Listen the question carefully. They asked to identify which one is act as a limiting reagent, and they also asked to calculate how much amount of product C formed in the equation. Now this is our balanced chemical equation, students. According to this balanced equation, what is the coefficient here? 2 is the stoichiometric coefficient. So let us express this one in terms of moles. So 2 moles of reactant A, 2 moles of reactant A combines with 4 moles of reactant B. It forms 3 moles of product C and 4 moles of product D. Listen this first explanation carefully. Already we solved this type of problems under stoichiometric calculation, students. So in this case also you please express this balanced equation in terms of number of moles according to the balanced equation, according to the balanced chemical equation. 2 moles of reactant A, 2 moles of reactant A combines with 4 moles of reactant B. 2 moles of reactant A combines with 4 moles of reactant B. So therefore X moles of reactant A required to react with 6 moles of reactant B. Either you use number of moles of B and calculate number of moles of A, or use number of moles of A and calculate number of moles of B, students. Now here in this I am using number of moles of B and I am going to calculate number of moles of A here. According to the balanced equation, 2 moles of A are react with 4 moles of B. So therefore X moles of reactant A react with 6 moles of reactant B. So let us cross multiply these two. 6 into 2, denominator 4. 6 into 2, denominator 4. 2 ones are, here it is 2 twos are. So 2 ones are and here it is 2 threes are. So how many moles of reactant A are required, students? 3 moles of reactant A are required. Please listen this point carefully. Nodri ಎಷ್ಟು ಬೇಕಪ್ಪ ನಮಗೆ reactant A 3 moles ಬೇಕು. But given the problem how many moles of A are present? 5 moles are there. But required is how much? Only 3 moles. The required quantity is less than that of available quantity. That's why reactant A is called as an excess reagent. Please try to understand the explanation. ನಮಗೆ ಬೇಕಾಗಿರೋದೆಷ್ಟು just 3 moles ಬೇಕು. But quantity available ಇರೋದೆಷ್ಟು ನಮಗೆ 5 moles. ಅಂದ್ರೆ 3 moles ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡ್ರು ಇನ್ನೂ ನಮಗೆ 2 moles of A ಏನಾಗ್ತಾವ್ರಿ ಎಕ್ಸೆಸ್ ಉಳಿತಾವು. ಅದಕ್ಕೆ ನಾವು ಇದನ್ನ ಏನಂತೀವಿ ಎಕ್ಸೆಸ್ ರಿಯೇಜೆಂಟ್ ಅಂತ ಕರೀತೀವಿ. If A is called as an excess reagent means which one is called as a limiting reagent, students? B is called as a limiting reagent. So ಯಾವುದು limiting reagent ಆಯ್ತು ಹಾಗಾದ್ರೆ B is act as a limiting reagent here. ಅಂದ್ರೆ ನಾನು ಇಲ್ಲಿ ಏನು ತಗೊಂಡಿದ್ದೀನಿ B ತಗೊಂಡು A ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದೀನಿ. ಹೌದಾ? If you want you can take A and calculate B also, or 2 moles of reactant A combines with 4 moles of reactant B. So therefore 5 moles of reactant A combines with X moles of reactant B. So cross multiply these two. So X equal to 5 into 4 denominator 2. 5 into 4 denominator 2, 2 ones are, 2 twos are. 5 into 2, how many moles of B2 are required, students? 10 moles of B are required. That means the required quantity is more than that of available. So in the problem we have only 6 moles of B, but required is 10 moles. Therefore all these 6 moles are completely consumed during the chemical reaction. Hence B is act as a limiting reagent. So either you can solve this one or you can solve this second one. Any one you can solve, students. A ತಗೊಂಡು B ನಾದರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ, B ತಗೊಂಡು A ನಾದರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ. Just tell me students, which one is a limiting reagent here? So reactant B is limiting reagent in this problem. So in the question, the second problem is they asked to calculate the amount of C formed. And the balance equation is 2A plus 4B, right hand side 3C plus 4D. So once again express this balance equation in terms of moles, students. And according to this balanced chemical equation, we identify which one is a limiting reagent here. Yes, tell me student, which one is a limiting reagent? B is a limiting reagent. And you please recall the sentence, the product formation always depends on the quantity of limiting reagent. And which quantity they asked? The quantity of C form. They asked to calculate amount of C form. So they, according to this balanced equation, 4 moles of reactant B, 4 moles of reactant B produces 3 moles of product C. Under balanced equation prakara 4 moles of B, 3 moles of C in the product. So therefore, how much moles of B are required here? 10 moles of B are required. Then how many moles of B are available? 6 moles. So therefore 6 moles of B required produces X moles of C. So available is 6 moles. Reacting limiting reagent क्या B, हौदा 4 moles equation प्रकार 4 moles of B produces 3 moles, therefore 6 moles of B produces X moles of C. So cross multiply these two, X equal to 6 into 3, denominator 4. So 6 into 3, denominator 4. So here it is 18 divided by 4. 4 ones are, and here it is 4 fours are, then 0.5. So what is the final answer, students? 4.5 moles of C are formed here. Is there any doubt up to here? This is clear. The third problem is 1 gram of magnesium, I repeat, 1 gram of magnesium burnt with 0.5 gram of oxygen. Listen the first sentence carefully, students. So 1 gram of magnesium burnt with 0.5 gram of oxygen. And the question is, identify the limiting reagent and calculate the amount of magnesium oxide formed. And based on this first sentence, 1 gram of magnesium burnt with oxygen. So two reactant, listen the solution carefully. One of the reactant is magnesium atom and the second reactant is oxygen. Magnesium burnt with oxygen. When it burns with oxygen molecule, it leads to the formation of magnesium oxide. So based on the first statement, based on the first sentence, you frame the skeleton equation. And after writing this skeleton equation, by using suitable numerals or by using suitable numbers or by using suitable stoichiometric coefficients, so you please balance the skeleton equation first. Now here in this skeleton equation, so two oxygen atoms are present on the left hand side and right hand side we have only one oxygen. So one oxygen means odd number. So first to make this odd number into even by multiplying this magnesium oxide with a suitable stoichiometric coefficient. So let us multiply this magnesium oxide by 2. Now 2 into O. So 2 oxygen atom on the right hand side and 2 oxygen atoms on the left hand side, students. Now the oxygen atoms are balanced. The second atom in this equation is magnesium atom. Left hand side we have one magnesium atom, whereas right hand side we have 2 magnesium atom. So to make this balance, let us multiply this magnesium atom by 2. Now left hand side 2 magnesium and right hand side also 2 magnesium atoms. Now this is our balanced chemical equation, students. After balancing the chemical equation, let us express the reactants and products in this equation in terms of moles. So here what is the coefficient, students? 2 is the coefficient, that means 2 moles of magnesium. Then what is the coefficient here? 1 is the coefficient, so 1 mole of oxygen. So 2 moles of magnesium burns with 1 mole of oxygen. It forms 2 moles of magnesium oxide. But in this problem, magnesium is given in terms of mass, even the oxygen is also given in terms of mass. 1 gram of magnesium is given and 0.5 gram of oxygen is given, student. So let us express the reactants and the products in terms of mass. In terms of mass, you keep this coefficient as it is. Magnesium, what is the atomic mass of magnesium, students? As you please recall the concept of atomic mass. Tell me what is the atomic mass of magnesium? So 24 is the atomic mass of magnesium. So 24 into 2, 48. 48 gram of magnesium. So this 48 gram of magnesium burns with 1 mole of O2. O2. 2 oxygen atoms are present here. The atomic mass of 1 oxygen is 16. Like there are 2. 16 into 2, what is the answer? 32. So 32 gram of oxygen. Listen this point carefully. It forms 2 moles of magnesium oxide. MgO. 1 magnesium and 1 oxygen. Atomic mass of magnesium is 24 and atomic mass of oxygen is 16. So 24 plus 16. 24 plus 16 is equal to 40. The molecular mass of magnesium oxide is 40. Like there are 2 moles. You keep this coefficient as it is. So 2 into the gram molecular mass of magnesium oxide is 40. Now 40 into 2, 80 gram. This is in terms of mass of the chemical substance. Students, according to the balanced chemical equation, according to this balanced chemical equation, 48 gram of magnesium burns with 32 gram of oxygen. Now let us calculate how much amount of magnesium is required to burn with. 0.5 gram of oxygen. So let us calculate the amount of magnesium required. So you cross multiply these two. X equal to 0.5 multiplied by 48 divided by 32. Listen here, 0.5 into 48 divided by 32. 5 into 48 divided by 32, you will get 0.75 gram. But in the problem, the available amount of magnesium is 1 gram. ನೋಡಿ ನಮಗೆ ರಿಕ್ವೈರ್ಡ್ ಇರೋದೆಷ್ಟು ಜಸ್ಟ್ 0.75 ಗ್ರಾಮ್. ಬಟ್ ನಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಒಳಗೆ ಕೊಟ್ಟಿರೋದೆಷ್ಟು 1 ಗ್ರಾಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ. Required is 0.75 and available is 1 gram. That means required quantity is less than that of available quantity. So that's why magnesium is called as an excess reagent in this problem. If magnesium is act as an excess reagent, means the other reactant is called as a limiting reagent. That means in this problem oxygen is act as a limiting reagent. Students, so either you take magnesium and you calculate the oxygen, or use amount of oxygen and you calculate the magnesium. ಅಂದ್ರೆ ನೀವು ಮ್ಯಾಗ್ನೇಷಿಯಂ ತಗೊಂಡು ಆಕ್ಸಿಜನ್ ಅಂತ ಅಮೌಂಟ್ ನಾದ್ರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ, ಇಲ್ಲ ಆಕ್ಸಿಜನ್ ಅನ್ನ ತಗೊಂಡ್ಬಿಟ್ಟು ಮ್ಯಾಗ್ನೇಷಿಯಂ ಅಂತ ಅಮೌಂಟ್ ನಾದ್ರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ. Okay, either you will get excess or you will get limiting reagent. Students, in this problem I use amount of oxygen and I calculated amount of magnesium required. Either you can use this calculation or you can use this calculation. Either you take mass of magnesium and calculate the mass of oxygen, or you can take mass of oxygen and calculate the mass of magnesium. Students, anyone. ಸೊ ನೀವು ಮ್ಯಾಗ್ನೇಷಿಯಂ ಅನ್ನು ತಗೊಂಡು ಆಕ್ಸಿಜನ್ ಅನ್ನಾದ್ರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ ಅಥವಾ ಆಕ್ಸಿಜನ್ ಅನ್ನು ತಗೊಂಡು ಮ್ಯಾಗ್ನೇಷಿಯಂ ಅನ್ನಾದ್ರೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ. So now with this calculation we come to know that in this problem, so in this balanced chemical equation, oxygen is called as limiting reagent and magnesium is called as excess reagent. Students, calculate the amount of magnesium oxide formed according to this balanced chemical equation. Which one is the limiting reagent, student? Oxygen. So by using this balanced chemical equation, 32 gram of oxygen, when it burns with magnesium, it forms 80 gram of magnesium oxide. This is by using balanced chemical equation, students. No need to use magnesium in this explanation. ಯಾಕಂದ್ರೆ ಲಿಮಿಟಿಂಗ್ ರಿಯೇಜೆಂಟ್ ಆಕ್ಸಿಜನ್ ಅಂತ ನಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ, ಹೌದಾ? ಸೊ ಅದಕ್ಕೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಆಕ್ಸಿಜನ್ ಅನ್ನ ತಗೊಳ್ರಿ. ಸೊ ಅವ್ರು ಕೇಳಿರೋದೇನು? ಮ್ಯಾಗ್ನೀಷಿಯಂ ಆಕ್ಸೈಡ್. ಓನ್ಲಿ ಯೂಸ್ ದೀಸ್ ಟು ಸಬ್ಸ್ಟೆನ್ಸಸ್. So according to the balanced chemical equation, 32 gram of oxygen when burns with magnesium, it forms 80 gram of magnesium oxide. So therefore how much amount of oxygen is given, students? 0.5 gram. So therefore 0.5 gram of oxygen when burns with magnesium to produce x gram of magnesium oxide. So now you cross multiply. So cross multiply these two. X equal to 0.5 multiplied by 80 divided by 32. 0.5 into 80 divided by 32, you will get the final answer 1.25 gram. So this much amount of magnesium oxide is formed when 0.5 gram of oxygen burns with magnesium atom. So this is the final answer, students. What is the answer here? 1.25 gram. So like this you have to calculate the amount of product formed by using this limiting reagent part. Is there any doubt in this concept? Any doubt in this problem? This problem is clear for you? So based on today's class, in the assignment, two problems are given in today's class. So both the problems are related to the limiting reagent concept only. And before solving these two problems, once you please go through the solved problems. Already 3 problems are solved. Once you please go through all these 3 problems and then you start solving these assignment problems, students. Okay, so with this I conclude my today's class. Thank you.